My name is Ugochukwu Obunaya and spread the gospel. Thank you so much. I look forward to much more and exploring my skills in the world at large for impacting God's kingdom. My name is Ugochukwu Obunaya for impacting God's kingdom.
Hello, everyone. Welcome to today's class. I'm so happy to be here and to meet you all. Can you hear me now? Awesome, awesome. So, today we're going to be starting the class Software Development Lifecycle, which is a continuation of Introduction to Software Development that you had earlier. My name is Oluwabusola Adeleke, and I'm a senior software engineer at E5 and at RAD. And I'll be taking you through the class Software Development Lifecycle. Welcome once again. Okay. Today we are going to cover what is software development lifecycle, what are the phases of software development lifecycle, the requirement, the design, the development, the testing, the deployment, and the maintenance. We will also cover the challenges and solutions, especially the common issues in software development lifecycle and the practical ways to overcome them in order to have a very beautiful project at the end of the day. We'll also go through the case study, which is one example of a real-world example that is demonstrating software development lifecycle in action. And we also have questions and answers and key takeaway, which will lead you into the next class that you will have later. There, I'll be addressing the questions and also summarizing what we've talked about. What is software development lifecycle? In simple words, explaining like I'm talking to a 5-year-old is like the implementation and then checking what type of model you will need and evaluating the model and reevaluating again to know if that model you have chosen actually fits into what you want to do in order to execute a project. That is basically what the whole software development life cycle is all about. Now, if we want to define it, what is software development lifecycle? It is simply a step-by-step process that development teams use to create high quality, cost effective, and secure software. You will agree with me that these are actually what you actually need to deliver a good software. Now, I'll start using the word SDLC instead of repeating software development lifecycle. This SDLC breaks down software development into distinct repeatable stages, and it provides a roadmap that helps organizations to create software that meets the stakeholders' needs and customers' expectations throughout the software's life cycle. That is from beginning to the end of the project. Why are we talking about software development lifecycle? It is to avoid chaos, to reduce costs, and to meet users' needs. Let us take a look at the diagram on the screen. You will realize that the chaotic code, nobody understands it. It is only in that user's brain, whoever is developing it. It is only that person that knows what the ones and zeros are. Now let us check the organized workflow. You can see that it is not even showing any human. It is showing a logical arrangement of the ideas and the things that have been selected. In this case, the zeros have been selected out of circles, squares, and triangles. Let's go back in time to find out what is the history of SDLC. It actually started around 1960, where they introduced the waterfall methodology, and then moving down to the modern era, where they now transition to agile and DevOps practices. Now we'll talk about the phases of software development lifecycle. In the image beside planning and analysis, you will see that we have like 7 items in that diagram. The first one on that place is planning and analysis. And this is for the feasibility study, right? And resources allocations. Now, what exactly is planning and analysis? This is the point where the software development team, they brainstorm basic high-level ideas about the projects. What are they brainstorming about? They're talking about the use case it will help them solve, who will use this product, that is the users, how the software might interact with other applications and systems that they already have or they wish to have in future, and what are the business goals and risks that it involves. This is what happens at the planning and analysis stage. Once that one is done, then we go ahead to the requirement gathering. At this point, the development team conducts market research and feasibility testing. Is this thing feasible? Who are the people that will use it in the market? They evaluate the prototypes, maybe the things that are already in existence. They try to check it out. How is it going? Is this product really useful? Then they allocate resources. How much are we willing to invest in this? And they also establish what is not needed. Because if this is not put in place, the project might become bloated. It might go out of way. And the reason for creating that project might even not be addressed. And that is why it is important to note what is not needed. After all these things have been put in place, they go ahead to draft the software requirement specification document. So I'll just go ahead and call it SRC document. This includes the functionalities of the software, all the necessary resources, the possible risks that could come up, and the project timeline. These are the things that help the team stay on task throughout the project. Now, what next? After requirement gathering, it goes on to the design. This is where you design both the front end that the user will see and the back end, which includes the project's architecture. And what does the project architecture outline? The software's navigation. Where will the user start from? Where will it take the user to? What experience is the user supposed to have? The user interface, which people normally design with Figma and the rest of it. Then the database design. This is very important because it is like the foundation of your project. You have to know the type of database that you want to use and why. Is it SQL? Is it NoSQL? And the rest of them. And both is easy to operate for end users and easy to integrate an organization's current system. So that means if an organization already has something in place and they just want to do this like a better, like addition to what they already have, we need to consider that in the design as well, to say, do we have users already in the system? This thing that we want to integrate, that we want to develop, how do we integrate these current users with the old users? How do we match them together without causing a conflict? All this work is collected in the software design, which is passed on to the developers as the roadmap to use while coding. Okay. The team starts to write code and build. This is what they do at the development stage, specifically using what is in the design and the requirement gathering phase as guidelines. That's the SDD document and the SRC document. It is very important to follow this requirement, else there will be a conflict later in the project. This also helps them to decide which type of coding language they want to use. And it helps the project manager to now divide the project into smaller district coding tasks. Because since they know the beginning and the end of the project, it's easier to break it down bi-weekly on how they want it to work. After every development has been done, the next step is testing stage. Now, this testing is as important as any part of the application. And I will tell you the reason. Have you ever gone to an application or a website and you just wonder, why is this like this? This is due to the fact that there's a little bit of thing to be implemented by the quality assurance team. A quality assurance team performs several types of tests to make sure that all the parts of the software work as intended. They make sure that it meets the user the stages are right on the right hand side. On the right hand side, you can see that diagram, and on the left hand side is what I'm talking about. Kindly confirm you can see the slide. Please confirm you can see the slide. Okay, thank you very much. All right. So the image is really not important, and the reason is because it's like an icon just for you to have an idea that we have 7 stages. The main thing I'm talking about is on the left hand side, which we are currently talking about now, which is testing. So you really don't need that image. It is just like a silhouette, just to understand what we're talking about, just to have a total capture of the essence of our discussion. Awesome. So we were talking about testing. The quality assurance team performs several types of tests to make sure that all parts of the software work as intended. They make sure that it meets user and business requirements and works within the organization's broader IT environment. Right. So this is the main essence of the testing stage. Now we're going to have a breakdown of the types of software testing. The first testing we have is the acceptance testing. What do we mean by acceptance testing? It is verifying that the whole system works as intended. Is this what is in the Figma? Is the user seeing what is expected to see in the Figma design that has been accepted? Is it saving as it's supposed to save? That is the acceptance testing. Then we go on to the code review. This is at the point where the developers, the senior or the lead developer on the project, goes through the project and sees if the code is according to standard and it adheres to best practices. Now, at this code review, it depends on how wide your department is and how many team members you are working with. There is peer-to-peer review before you now have a final review, and then before it is merged. This is to ensure that limited errors are merged into the system. Moving on to integration testing. This is to ensure that the software components or functions are well integrated with the rest of the code that are currently in the system and working as they should. Okay. We also have unit testing. This unit testing validates that each software you run are running as expected. This one is basically writing a code whether using jest or other form of languages to write a small code that runs your code that you have written. So you have a test file that runs the code file that you have written and checks for all the points and validates that everything works as expected. And if, for instance, there's a little bit of change in it, the test fails, what happens? You have to ensure that your test passes, check what needs to be done before you finally submit for review. We also have functional testing. This functional testing is checking the functions by emulating the business scenarios that we have based on the requirements in the SDLC document. The black box testing is a common way to verify functions. Now, let's go to the deployment stage. The software development team, this is the point where they release to production. They can decide to release in production like a whole, that is the big bang, like everything is out at once, or they do a phased rollout. These are the points where you see things like coming soon. You see some part of the application we have coming soon. But the big bang is like everything is working as expected from beginning to the end. Now, this might involve deploying the software in stages, like beta release, where some groups in the company will first of all test it and understand the system and see that it's working as it is supposed to work. After this has been concluded and everybody in the beta test are happy with the implementation, then they move ahead to create manuals. They conduct training sessions or even offer on-site support for the users. All these stages are very, very important to ensure that everybody understands the goal of the software and they can relate with it and work with it and enjoy it, because that is the main essence of creating the app, to make life easier. And this must be achieved by all the sessions, all the manuals, creating FAQs on the website, if it is a website. Now, it has been deployed, but that is not the end of it. We now have the maintenance stage. During this phase of software development lifecycle, software engineers continue to push software updates. They fix some tests, they see some bugs and they fix them. They upgrade, they add some new things if they want to make it better. And in some software development models, such as DevOps model, the team will use continuous integration and continuous deployment. We simply call it CI/CD. This is an approach where code is continuously added to the code base as it's written. And they have done it in such a way that once you deploy, what happens? It's to production straight. This is, I don't know if you have heard this joke, but there's a joke like, Don't deploy your app on Friday because the whole thing might go on fire. Those are those using CI/CD deployment. Because once you push it, it is live and everybody gets the effects immediately. Let us go on a break now. And on this break, I will be asking if there are challenges that we have been facing since we started this class, or if you have any questions so far. Please type it in the comment section. This is the Software Development Lifecycle class. I'm sure you will get a slide about the previous class as well. Yes, CI/CD is like updating the app. It's continuously integrating and developing it. You will receive the slides after the class. So the CI/CD is like the process of quickly updating. You will get more explanation on this in your next class. But it's simply a process where you can just create the application and then write some coding lines, and boom, it is deployed. The attendance will be later in the class. SDLC is Software Development Lifecycle. Okay. Someone wants a quick recap on the class. All right. For those who want a quick recap on the class, I'll simply just take us all through. Okay. Let me try to answer the questions in 3 minutes, and then I'll give us like a quick recap before we continue. Is the SDLC important? It is very important. In fact, a project that does not follow the software development lifecycle is almost bound to fail. Because when you don't have a destination, you will just hover around and over around, and the project might not have an end. Someone said I am too fast. Okay. I will try to have a recap of the whole application. You will get the slides for the class. Don't worry, both the last class and this current class. I will give a quick recap in the next 2 minutes. I just want to see if there are other questions. In the upcoming class, you will get to know more about CI/CD. So don't worry, let's take it one step at a time. The apps we are going to be using for this lesson, these ones are still introductions, so we don't need an app for now. But as we proceed, we will be using some softwares, but not in this class. This class is basically for introduction. The programming language depends on what you are building. So it is actually determined during this software development cycle what you intend to do, and that is how you determine your language. About the code you will need to test our software, that is unit testing, where you write some unit test file. It's just like writing a code. Like, let's assume you write print hello world. Now you have another file that is a .test file that says check if this project actually prints hello world. So if your test fails that and does not replicate the hello world, that simply means what? The test has failed and something is wrong. It's either your hello world is not working, or that the application has an issue. So you need to fix it. So it's 7:30 now, and I took this break so that I can look through the questions that people are having. And right now we're going back to taking a recap of what we have before we proceed. Okay, so we talked about the introduction, the history, and why. These are the things that we have talked about so far. Why SDLC? Why are we talking about it? To avoid the chaos, to reduce cost, and to meet user needs. I believe this has answered some people's question in the chat. And then we go on to the history and then the phases. And in the phases, the picture beside simply shows the planning, the requirement gathering, the design, the development, the testing, the deployment, and the maintenance. All right. So we talked about the requirement gathering as well, where we have the SRS document. We talked about the design, where we have the project architecture, where we have the user interface, where we have the database design. We talked about the development, where the team starts to write the code and build the software using the SDD and the SRC guideline, which helps the user to know the right coding language to use, as somebody asked earlier in the class. We also have the testing phase. This testing phase was where we summarize and on all the types of testing that we have in a project. And that is how we have the image on the right hand side, which shows functional testing covering the business scenario, the black box testing. We have the regression testing, which features the degradation and the sanity testing. We have the unit testing, which talks about the unit validation. We talk about strain capacity from the stress testing. So you know it, what kind of load can it carry? How many users can hit this app before it crashes? These are the things that you check on the stress testing. The integration testing, the component compatibility with what you have earlier in the system. The acceptance testing, that is where you check for the system verification. And then the code review and the best practices are what you do. And then you have the load testing to check the performance. All right. Now, and we talked about each one of them, elaborating and breaking it down, where we have the unit test, the functional, then the performance, the regression, security, stress, and the deployment. That was where we were before we took that break. And now we are going to go to the challenges. You see, these challenges are the reasons why we create those documents we mentioned earlier. The software development lifecycle challenges include inefficient SDLC processes. So when you don't do it well, what happens? There is unclear objective and scope creep. So let's say we want to build an app where people can just register for this class. But when they started, they felt like, oh, can we add the view? Can we add a mail to send to them? Can we add WhatsApp message integration? You see, that is an unclear objective, and there are a lot of things that are creeping in. And this will end up causing what? The project to never have an end. Another thing that can cause inefficient SDLC process is underestimating the time it will take. Now, for this one, if there are insufficient resources, let's assume what you want to build is supposed to make use of 10 software engineers. Let's say 5 seniors, 2 mid-level, 3 juniors. And then all of a sudden, something happened and there's a change. Maybe the developers reduced to 7. There is going to be a change in that testing time. And the insufficient resources can affect the planning, making it inadequate, and then causing a discrepancy at the calculation of the time it will take to complete the project. What about poor communication? Misunderstanding what somebody is saying or what the document entails. If that document is not clear, there might be misunderstanding in what the expectation is. Now, lack of collaboration is another thing. The PMs, the project manager, the testers, the quality assurance testing team, the developers, both the front end and back end, the DevOps team, if they are available, the database management team, everybody must be in sync. Else, it is going to affect the project due to poor communication. Let's move to ineffective methodologies. There is lack of adaptability. And there's rigid processes. You see, when your app cannot adapt to what is currently in the system, especially for those that have a working app in progress and they just want to add new things to it, this can cause a big harm in the project. Now let's elaborate on the scope creep in software development. In instances where the stakeholders are not sure of their expectations, what happens? Can somebody answer in the group? In instances where the stakeholders are not sure of what they want, what do you think will happen? Where they're like, I'm not sure if we are needing, if this project is for 100 people or for 1,000. I'm not really sure. Maybe let's just start. Exactly. Somebody said chaos. Exactly. Conflict of choices. See, these are the things you give them what you intend, but then they are not sure of what they want. So, how are you so sure that what you will give them will be what they will want? What happens in this instance is that when you are done, they will tell you you are not done. Yes, confusion. Exactly. Exactly. And then everybody is frustrated because they don't have, they've put in a lot of effort, but then the client is not appreciating it. And you know, customers are always right. And once your customer is not right, it goes back to say, what did we discuss? And because there's no document to back it up, I'm sorry, you will have to keep going over and over and over until everybody is tired. So it is very important to plan explicitly how they want it to be done. In fact, it is best to spend a lot of time on getting the stakeholders' expectations. Some spend months getting these expectations right, so that once it's done, the time starts counting and then the project has an end. Let us go to the market pressures. Now, can somebody tell me what will happen if we develop a project based on competitors? Like, oh, this person has released, this person has released, this person has released. So let us quickly deploy our own. What do you think will happen? Can somebody respond on the comment section? Market pressures. What happens when you push out based on market pressures and you don't implement, you don't complete the whole software development lifecycle processes just so that you can make up with market pressure? What happens? Frustration, chaos, loss of customers, incomplete work. Very good, very good. The work will be incomplete because everybody is just joining together. Anything that goes, very good. Somebody said half-baked. Somebody said full of bugs. Very good. Errors won't meet desired needs. Underdeveloped projects. That's where you have technical debts. That underdeveloped project, we call it technical debts. Yeah. Somebody said wahala. Yeah. So many things will happen simply because there is scope creep. And this happened because the software development lifecycle was not properly completed. Now, what about stakeholders' feature addition? This is another thing that happens in scope creep. When I already said, okay, what I want to develop is just a form, if the stakeholder came and said, no, just develop a form, let the user just submit, and that's all. In fact, don't send them a mail, I don't want anything. And then unadjusted timeline comes. Can we add this? Can we add this? Can we add this? What about this? Then the budget changes. Remember, you are posting it somewhere. Remember, you have allocated some developers for it. Remember, you have stated a timeline for that project, especially for consultants who take on projects for a period of time, and then they allocate developers to it. And once they are done, they move on to another project. So in that case, what happens? Everything becomes scattered. A big headache for the developer because you are working hours, but there's no effect. Now, let's go to what the impact on project. What's the impact? What's the impact? What can we say about the impact of the scope creep? What can we say about the impact? What happens? Disagreement and disappointment, yes. On the project itself, yeah, loss of funds, wasted effort. Exactly. What about the delivery of the project? Would it be in time?
Hi there, my name is Praise Oladipo and I'm in bootcamp. Thank you, Incubator. Hi there, my name is Praise Oladipo and I'm in the content and copywriting class. It has been amazing so far and my expectations have been surpassed. As a budding graphic designer, this has helped me a lot, taught me a lot on how to write better, how to write very creative copies. I'm so
My name is Akin, says no previous knowledge about this thing would actually understand. So yeah, the classes has been amazing. We've had group works, lots of presentations, and I would actually recommend this to everyone. And I just want to say a very big thank you to Incubator.
Hello, everyone. Apologies, sincere apologies, and I'm back like I never left. It was beyond the situation, was beyond control. Thank you, guys. Thank you so much for your patience. Thank you, thank you, thank you. I sincerely appreciate your patience, and it's good to be back. Yes, your teacher is back. Thank you, guys. Thank you for your patience. Really appreciate it. Okay, so now that I'm back, I'm glad to tell you that for those asking for their attendance, yay, it is time to fill your attendance. So I'm going to give you 5 minutes to go ahead and fill up your attendance. Yeah, I am very much here. Everybody is still here. Everybody is still here. Yeah, thank you very much. So go ahead and fill your attendance. We have 5 minutes to do that, please. 5 minutes to do that. Okay, I believe every one of us is done with our attendance now. Awesome, awesome. Who is ready to continue learning? Say, I am ready in the comment section. I am ready. I'm ready. I'm ready. Yeah, because this section of the class now is going to be very, 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 very interactive. All right. So, let's talk about the SDLC challenges. The SDLC challenges that we're talking about and the impacts it will have on the project. Since we are elaborating on those challenges, right? Now we're going to have the next one. You know, we talked about scope script the other time. Now we're going to talk about insufficient testing time. Insufficient testing time. All right. You see, this insufficient testing time, there's so many things to it. And we're going to take it bit by bit. Let's start with over optimism. What do you think it means? What do you think it means? Over optimism. Somebody in the comment section, please. Tell me what you think it means, over optimism. Over optimism. Can you see my screen? It is the yellow tab on that screen. Yeah, it means overzealous, too positive. There's something that's called it too sure me die in pidgin. Right, exactly, being too sure. Like this one would just be it always amounts to insufficient testing time. All right, and this over optimism includes ignoring the complexity and ignoring the initial timeline. Right. So let's assume they just say they want to build something. You did not dig deep into what they want, and you just assume, this one, we've done it before now. Give us 2 months. Give us 2 months. And the client has gone ahead to meet the media team, to meet the brand ambassadors, to say, okay, we're going to sign a contract with you in 2 months. You will help us to advertise this product. Whereas you are not even sure that you can deliver in 2 months. All right. Yes. So in everything, they always result in nothing good. Even when you are very sure, create the space, create the risk assessment for plus or minus. If something goes wrong, what if? Create the space for it. Right. No matter how much you have planned, some things might still not go the way you intend. But when you create backup plans for it, alternatives, and spaces for it, it helps you to balance up, and the effects will be close to little or nothing. Now, let's consider the edge case of neglect. You know, for every instances, there are some edge cases one needs to consider. You need to consider some instances, some exceptional cases. And when you are integrating complexities, especially a complex application, it could be web, it could be Android, you need to understand that there are some complexities and not all those edge cases. Imagine a learning platform that allows user to sign in and then take an examination. But you have forgotten to put into the edge case, like what happened during this class, where there's disruption and then the person comes back. If you don't put the edge case of the person being able to continue the exam on that learning platform, what do you think will happen? What do you think will happen in the chat? Let's assume you have 1,000 students and there's disruption in some class, and then maybe let's say 500 students had some hiccups in the exam. What will happen if you don't consider the edge case of returning candidates during that examination? The exam is ruined. It's either people fail or they retake that examination. And then it forfeits the essence of what? The project in the first place, because it's supposed to be remote. So this is, in fact, massive. Somebody said massive failure. Exactly. You can imagine something submitting before the students are done, and examinations are not supposed to be done twice. That means the questionnaire will have to be set again. So many things will go wrong just because of edge case neglect and the complexity of the integration. And this can happen when there is not enough time to test. Let's quickly go to the market. The customer is already waiting. Let's quickly deploy it. There's no problem. But if they have tested well, what will have happened? They will have seen that, oh, I experienced this. Let us fix it before we deploy the application. Oh, somebody said common during CBT examinations. Can you imagine? And that is very sad. Okay, let's go on to deadline pressure. This is another reason why we always have insufficient testing time. Deadline pressure. Rushed workaround. The non-development phases, like that requirement gathering, like that design, like the end-to-end and processing, checking. If they cut around it, somebody was asking me earlier in this class that what happens if we don't do this SDLC? What will happen? This is what will happen. There will be deadline pressure because you have been adding 1 and 2 and 3 to what is just supposed to be 1. There will be rushed workload. There will be non-development phases that you have cut off, that should have prevented, that everybody should be looking at it like a map. Like, oh, we have done phase 1, check. Phase 2, check. Phase 3, check. All right. Now, what is the impact on production? Somebody already said it's CBT issues. Unfortunately, there will be bug in production. That is just the impact. There will be bug in production. There will be costly post-launch fixes. Like that is after you have launched the project, you are now fixing. Trying to mend the leg when it's already broken. This could have been avoided if they have tested well. Somebody said the words are not clear. Don't worry, when you get the document, you will see it properly. All right. What other SDLC challenges do we have? We have lack of cross-functional collaboration. You see, in a team, we have so many things. We have the testers, we call them quality assurance testers. We have the project managers, we have the product manager, we have the DevOps team, we have the developers, the front end, the back end, and the other team members. If this collaboration is not in sync and the developer and testers are not working hand to hand, what do you think will happen? I want your answers in the comment section. What do you think will happen? You can imagine the developer and the tester. They are working in isolation. What will happen? It will be full of errors because they're a team. The work of the tester is not to be your friend, is to check out for issues and problems in the application. That is their work. Their job is not to look for the good one. So if they are not checking for the errors, what are you building? Because everything a developer builds is great in their eyes. It is only in the third eye that we can actually see the errors. It's simply going to be a bad project. There will be so much confusion. And remember, it's going to be a challenge on the project. Now, let us take cultural gaps. The technical teams, they don't understand the business needs. Remember that there's business need in that document shared, right? In the planning and gathering stage. Now, if the technical team do not understand that business need that was written there, either it was not explicitly written or it was not understood. And the business team likewise does not understand the constraints. Imagine the business team asking for there's nothing undoable, but there are some things that are just not feasible for the technical team. If there is no bridge between that understanding, the technical team understanding the business side and the business team understanding what the technical team can do and the constraint they have, quality issues will result. Somebody said underdeveloped products. There will be a big issue because there will be conflict. Exactly. Someone said conflict. There will be serious conflict. This takes us to the next one, which is ambiguous documentation. So, the documentation, remember that what will happen in the cultural gap is as a result of the technical team not understanding the business team exactly. Somebody said, pay me money first when you're ready with what you want. You These are all the things that happen when issues arise. These are the challenges that we have doing software development life cycle. Now, the ambiguous documentation that the business team has written, maybe writing something that is outdated or not incomplete. As little as it can be, could cause a big backlash on the whole project. Now, we also have misinterpreted requirements. Things that are duplicated, especially on the project side. This kind of issues happens a lot when the work is duplicated and then there are some tasks that are missed. Now, this takes us to the project management challenges that happens during the software development life cycle. We have the resources constraints, limited skills personnel, now, what are the resources? What are the constraints you can have with resources? You have outdated tools. Imagine having a laptop that is not in having the capacity to carry the work that you're doing. Or the limited skills personnel. Can you imagine what will happen if the developers are supposed to be 10 on a project with 5 senior software engineers turned to 2 senior software engineers or 1? What do you think will happen to that project? Regardless of how you have managed it, what do you think will happen to that project? Can somebody say it in the comment section? There will be delay. There will be serious delay. Exactly. And if there is no space for that kind of delay, it can affect the project. Disaster. The project will flop. These are the spaces that should be created. So even when you are given 2 months as the project, like that is what we take the project, you need to give extra 2 weeks, or just in case, or extra month, just in case something comes up, enough time for testing. Now, let us go to the technical debt. You see, this part is something that always happens in projects. How do I mean? When you're supposed to write a code and write the unit test for it, but you're like, no, the time has gone now. Let me just write the code alone and just push it. Let me push it. Let's test it like that. Just go ahead and test it. What do you think will happen? Or after writing the code, the person did not document. What happens? You feel like, Kebe, I know it now. I know it. What if that person is no longer on the team? Would you be calling that person every day to continue with the project? Remember the 4 senior engineers that left. If there is no proper documentation, what will happen? It will affect the life cycle of that software. But if there is proper documentation, it will help the project manager to be able to manage it based on all those things. Now, we have to go to the unrealistic timeline. Most of the time, the project manager goes to say, okay, you know what? How long will it take to do this? And the person says, oh, this will take 1 month. No, Shebi is just to do this. You can do it in 2 weeks now. That little sentence, you can do it in 2 weeks, can lead to the company losing money. A lot of money per microsecond. So it is important that there are no aggressive deadlines in a project. And there is no lack of technical input. So you have enough developers and you have reasonable timelines that is feasible. Now, what are the other types of challenges we can still have? The user engagement. Remember, some people, you are supposed to test that product during the testing phase. If the user engagement is not well done, what happens? The feedback cycle and the prototype will be different. So that user engagement time during the unit test is very, very, very important. Yes, I agree with you. There should be senior developers. That's why they have experience, and that is why they are needed in the system. Okay. The integration complexity. Now, let's talk about the legacy system and the API compatibility. Now, this is talking about the application itself in instances where the app is already working on the system and they want to add more to it. In that case, if it is not well done, there will be challenges. Let us move on to the breach risk. These ones are the security part of it. The security of an application should be integrated from the beginning of the project. If this is not well done and the afterthought of security is coming in place, the system might be hacked and the client might lose a lot of money. Meanwhile, during the requirement gathering, if the security has been put in place, would this happen? No, because they will have considered that breach, fix it, build the system around that security instead of having an afterthought about it. Now, we're going to have like a discussion. How does SDLC handle AI-driven projects? We've been talking about the regular project all this while. Please keep in mind, I'll come back to answer your questions once we are done with this phase because of the time constraints. How does SDLC handle AI-driven projects? You know, before, all the thing we just do is you give in, you take. If it is in database, you show it, and that is all. But as a software engineer, we want to understand what it will entail. Right. So for an AI development, it's quite different. And this includes you gather and define the system needs. Then you check the feasibility study. That is like you're checking for the data, right? The quality, the projects, and the budgets. I'm sure some of you might have heard that ChatGPT will say saying thank you costs a lot of money on the system because there's a budget for that thing. Either it is thank you that you have written or it is a question. It is the same query that is being sent. Right. So, how do I mean? Access data quality and budget for that project is very important. Okay, let's go to the design. How you plan the system architecture and models. Remember, whether you want to use Laravel or all these projects that are all these models that are available, you need to consider that in your design. The normal way we used to do it before, of course, you don't need that if you're not building an AI solution application. All right. Now, what is the next phase that we have? The development. In this development, you are training models. You are not just building codes and pushing and getting. No. These ones, you are training the model such that once you are done, what happens? You get what you need. And anything you do, the system, the machine will understand that language and keep building on it. Now let's go to the testing stage. This is where you validate that model and detect if there's any bias on that test that you have done. All the different type of bias that you can imagine, cultural bias, technical bias, any type of bias. You need to, at this point, test that your AI application is not biased. Now, on to the deployment phase. You integrate the models with the applications that you want. You already built the model, fine. Now you need to integrate it and see how it works with your app. I hope you know that your ChatGPT has a model, and that is why if you click on that option, you will see you will see so many models there. All right. Now, moving on to the maintenance. You now monitor and keep updating the models. This is where you will see something like beta version. Okay. Now, the key takeaway that we're going to have here at this point, I would like to share these key takeaways for this software development lifecycle. The things I want you to hold as there. Identify the issues by recognizing and analyzing the project challenges. Then implement improvements through any of the methodologies, either the Agile, the DevOps, CI/CD, which will be discussed in the next class. Then foster collaboration. Encourage cross-team communication. It is very important. Then ensure quality. Maintain high standard in the software. Don't push bug. Make sure what you are writing is the very best of what you could write at that point, no matter how hard it may seem. As you start coding, you will understand more of why this is very important. Then, to achieve the success, reach the project goals and milestone. Let your I'll be done by tomorrow morning be I will be done by tomorrow morning. Okay? And if there will be a shift in it, ensure you communicate well with your project managers or somebody managing it. So at this point, please feel free to drop your questions. This is the time to ask your questions. I know some people asked their questions earlier, but I couldn't answer as I was talking at that point. Yes, the slides were provided. Yes, either it is solo or it is a team. It is important to have software development lifecycle and do it diligently. It is very important for developers to follow. Remember that this software development lifecycle is like what it would take: the planning, the gathering, the design, the development, the testing, the deployment, and the maintenance. So if you miss anything out of it, for the person asking, what is SDD and SRC? SRS is Software Requirement Specification. And SDD is Software Design Document. That includes all those Figma, all those things, the layout for your backend. Yes, AI code will follow the SDLC, but it's quite different. And that was why I made that example of that AI, since that is what is in vogue now. And some software engineers might want to dive into it maybe later in their career. What is enough time for SDLC project development? This is based on the project you are working on. You cannot assume until you get that requirement gathering in right here, planning and analysis, and the requirement gathering. So these two things are what will help you to know your deadline, to know what you will need, and even the code language you will use to write the code. Lack of collaboration and unclear projects. Unclear project is when your software requirement specification document is not clear. This is what I want the app to do. This is how I want the app to be implemented. This is the experience I expect the user to have. You can't know the enough time you need until after you have gathered your requirements. And if you skip any one of those processes, you will end up having those challenges that we talked about. Is the SDLC necessary for small scale projects? Oh yes, either small or big. It is very important you plan, you gather your requirements, you design, you develop, you test, you deploy, and you maintain in that sequence. Can you please iterate on the AI lifecycle? It is almost the same as this normal one. The only difference is the models. You are developing the models and you are integrating the application. That is the only difference. Oh yes, it can be applied in web development, any application, as long as it is software. This life cycle is very important. And it gives you a lot of headache if you follow this cycle. And it is a cycle for a reason. Start from planning and end at maintenance. Don't start with maintenance and then plan in the middle. How is an AI trained to supply the required answer? I'm sorry, that is not in the scope of this class, but I'm sure as time goes on, let me just give you a brief. It is, you are also writing a code and you are training the model to catch and to be smart enough to understand the system and then continue from there and then improve based on what the user is inputting. Market requirement document, technical. I want to understand. So this is that is like us developers writing a report and then giving it to the client right before the exactly. So that is the software requirement specification document, that report that you're writing. And the client also goes through it. Remember, we mentioned something about business team and the technical team. The technical team will write it, give it to the business team. The business team will check it and understand the scope, if it captures their requirement, their market requirement. Ma, please, what market technical document in the software? Market requirement document is it's almost the same thing. The market requirement is what the business team are doing, while the technical is the one the technical team is doing. But there should be a sync. Can you please iterate on the AI life cycle? The AI life cycle is the same thing. The only difference is that we're talking about the models. We're adding the integration of the models in there. Coding, I want to understand. So this SDLC is like us writing a report and then giving, yeah. I started a project and multiple orders with the SDLC. How do I plan properly? Well, if you have started, you can still go back and try to take a pause and try to see if you have captured all the software requirement specifications. Right, and follow this principle. This thing on the, can you see what is on the screen? Follow from step 1 to step 7. Try to analyze it. How do we employ SDLC as new developers just getting into the market? As new developers, most of the time, except if you are a freelancer, that is when you will be in the system of from step 1 to step 7. But if you are working for a team, you might probably just be in development team, partially in testing, writing unit tests, maybe the design if you're on the back end, and then requirement gathering if you're a senior engineer. Can you see that these steps, they're like bits and pieces of the team coming together? But then if you are a freelancer, of course, you have to capture the whole thing. If somebody comes to meet you, you have to first of all plan and analyze it and then gather the requirements. But if you're working for a team, of course, it is on the design level that they will come to you after your team lead already has the SRS document drafted out. Right. Do we consider the stakeholders' needs or the market user concern while developing? You have to consider both of them. You have to consider both of them. And that is where we talked about the challenges earlier, business team and technical team. You have to come to an agreement. The CTO, which is the Chief Technology Officer, has to come in sync with the Chief Financial Officer to see that this project that we're building is it cost effective? Are we saving? Are we earning more than we are using? Right. Can only one developer follow? I'm trying to read. Do we consider stakeholders' need? Yeah. SDLC help us plan properly before we start. Yes. Do we consider the stakeholders' need? Both of them help us plan properly. Okay. Like for real, you're also a I will like to do. Okay, I think I have covered all the questions that we have, and we are so on course. Is there any other question that I maybe might have skipped? You can do well to add it. Our next class is going to be on software development methodologies, where you are going to be taught the agile, the waterfall, and the DevOps. What is your question that I skipped? Which area takes the longest? I know of a project that testing and debugging is taking the longest time in that project. So one thing that I have noticed is if you skip a part in the development stage, if you have pushed the bug will wait for them in the testing phase. So for issues that you're having in testing, is either the requirements are not well stated for the technical team, or there are some issues with the while developing it, coding and etc. A software developer is somebody that just develops the code. You develop the code, you have what you do, and you just develop. But a software engineer analyzes the layout step by step, the outcome. A software engineer follows the SDLC life cycle. understands the outcome of the system, not only what is happening right now, but even after. Okay. All right. I think we have answered all the questions. Thank you very much, everyone. And do enjoy the rest of your evening. Bye bye.
My name is Ugochukwu Obunaya in God's Kingdom. My name is Ugochukwu.